Now, after getting knowledge about this disintegration and radioactivity, we are now focusing on nuclear reactions again. Now, certain terminology about nuclear reactions, you are aware of radioactivity, we are aware of synthetic element production, we are aware of artificial radioactivity to that extent. Now we are focusing on some important topic that is there in nuclear part of chemistry or physics. No doubt, I can't separate out this topic from history also, because here history is playing vital role. So we are focusing on this topic, that is the production of nuclear bomb. Actually, French scientists and Italian scientists confirmed out data that when uranium is bombarded with neutron, slow moving neutron, we got traces of barium and krypton like elements. But why? They were not able to answer. Whereas German scientists Otto Hahn and Strassmann, I am revising the name, Otto Hahn and Strassmann, they concluded that this is happening because uranium atom is splitting out rather than converting out into something uranium-239 into barium and krypton like elements. Say, this is something new, because Dalton was giving some postulates of atom. He says atom of one element is not converted into atom of other element. But now you are aware transmutation is there, that is because of that one element is converted into another atom. So we are now having knowledge of that. But this is something great, that we are saying one atom is destroyed and new atoms are created, because Dalton is saying again same thing, that one cannot create atom and cannot destroy atom. But here one atom of uranium is destroyed, and instead of that barium and krypton, two atoms are produced. And we got this type of data that yes, it is possible. They put forward some reaction. According to them, there is uranium-235, that is the isotope of uranium that is responsible for this process, and not 238. Say plain, suppose I am saying uranium-238, it is bombarded with neutron, it should produce uranium-239, atomic number obviously 92. But when this is bombarded with neutron, it is undergoing splitting. We are getting barium plus krypton. Actually, I am saying barium plus krypton, but there are 20 different pairs, minor. But here we are showing this way, plus 2 to 3, not 2 by 3, 2 to 3 slow moving neutrons are also produced. So this way the reaction is there. This reaction is named as fission reaction. So I am revising, this reaction is named as fission reaction. Then our great scientist Albert Einstein, if you are using that principles, that mass is converted into energy, they checked out the detail and we got the data that if this reaction is carried out in proper way, tremendous energy should emitted in this reaction. So not only that, this reaction is associated with emission of tremendous amount of energy, which is, if we carry out this reaction in controlled manner, not controlled actually, but proper manner, then one can rise temperature greater than 1 lakh degrees Celsius. Imagine, it's very, very high temperature. And so, okay, why it is very, very high temperature? Because till that, with help of chemical reaction, one can't produce more than 5000 degrees Celsius temperature. Say that chemical reaction, we are calling that as active hydrogen or hydrogen torch. Say hydrogen gas is there in specific condition where oxygen is not present. In that condition, hydrogen is passed through arc, electrical arc is there. You are observed welding. So in case of welding, suppose I am touching out this rod over this, then there is production of flame. That flame is called as electrical arc. Like that, suppose between two electrodes, arc is produced and hydrogen gas is passed in absence of other gases. Then we are getting active hydrogen, which is having half-life period. You are aware. Say this is not radioactive. This is active hydrogen where its half-life period is 0.3 seconds. These active hydrogens are combining together and tremendous energy is emitted. At that time, one may rise temperature in range of 5000 degrees Celsius. This is called as hydrogen torch. That was the highest chemical temperature possible by chemical reaction. Whereas scientists were saying if we carry out this reaction in proper way, then one can rise temperature even more than lakh degrees Celsius. So nuclear chemistry is awesome. Simply, we can create new atom, we can destroy existing atom, we can convert one atom into another atom, and we can produce tremendous energy even never thought before, like that. And then scientists carried out this type of action in world, inclusive India. Scientists were engaged in order to produce this type of bomb, this type of reaction for production of bomb. Particularly this period is there before Second World War, where Hitler obviously was interested in producing this type of bomb, and so he invested tremendous amount in the production of nuclear bomb. But he was having certain ideas about Jewish scientists, and therefore he deported them. And then they went to America. For example, the great scientist Niels Bohr, another great scientist Albert Einstein. Niels Bohr escaped from Denmark with his 200 disciples. Germany lost out the world's greatest scientist this way, just because this type of fanatic ideas. They lost out the great scientist. At that time, he was knowing much more better about atom than any other person in the world in those days, even today. And his disciples. Albert Einstein also escaped. He went to USA. But still USA was not able to manufacture this type of bomb. To the surprise, another important scientist was there, that was there in Italy, named as Enrico Fermi, a great man in nuclear study, nuclear science, in the field of nuclear science. He proposed out nuclear model, how nucleus is there. That great man was there. He was also Jewish man, but he was not German, he was Italian. But Hitler's principle was there. Nothing is impossible for Aryans. After a few years, there was friendship between Mussolini, the dictator of Italy, and Hitler. And then Hitler asked him to deport Enrico Fermi also. And this way, America now got Enrico Fermi. Just imagine, these all scientists, Enrico Fermi, the nuclear scientist, Niels Bohr, atomic scientist, Albert Einstein knows about everything of atom. Like that, they were there in America. Whereas Germany was not able to produce nuclear bomb in spite of terrific research in the field. In Japan, scientists were also engaged in production of nuclear bomb. In case of India, Dr. Homi Jahangir Bhabha, our great scientist, he was also funded, but not for this type of work. That was for use of cosmic rays in order to make weapon. So like that, that world, particularly during Second World War, was involved in destructive work with help of science. Now why making of nuclear bomb was difficult? Simple reasons. Say, I am showing here uranium-238 and showing here uranium-235. On board I can show these two are separate, but practically we are getting only one substance from nature, that is uranium. Pinch blende is name of ore. From pinch blende, first lead is extracted, then uranium is extracted. If you want to get further knowledge, then polonium, another radioactive element, that is also extracted from that, and lastly radium is extracted from that. Now here we are getting uranium, but that is mixture of uranium-235 plus uranium-238. I am not able to separate out uranium-235 from uranium-238. Why? Because these two elements are called as isotopes of each other. What is isotope? Atomic number is same, that means number of proton is same. Iso 2 proton, that is called as isotope. So here we are getting same number of proton, that is 92 and 92, but mass number differs, so neutron number differs, and therefore these elements are called as isotopes of each other. They are having same chemical properties. Their physical properties are also similar. They differ little bit, but their nuclear properties are tremendously changed. Let us check nuclear property. Here uranium-238 on bombardment of neutron will give uranium-239, whereas uranium-235 on bombardment with neutron will split out into barium and krypton. This way their nuclear properties are different. I want to separate out uranium-235 from uranium-238, and it is a bit difficult task because their chemical properties are same. I can't separate out by using any chemical property. Their physical properties differ, yes, but little bit. And then they started out a process. Say uranium was converted into a compound uranium hexafluoride, UF6, because otherwise I have to melt and make it in gaseous state uranium, but now it's easy that we have to convert it into uranium hexafluoride, make it in gaseous form, and then pass through series of chambers. Here these chambers are there, like that series of chambers, and we have to pass it. Now here we are getting porous membrane. Every membrane is here porous. Now see, when I am blowing out this material inside, the gas which is uranium hexafluoride, why fluorine only considered? Because fluorine is only element in periodic table which is having only naturally occurring single isotope, that is atomic number 9, mass number 19. So when we are considering UF6 and UF6 means what? Uranium-238 and 235. It differs in mass with just 3 units because fluorine is having only single mass, that is 19. So this uranium is little bit lighter than this. So if I blow, then in next chamber little bit uranium-235 will be more. I am not saying only 238 remain here and 235 pass here, no, but amount will be little bit increased. Like that, if you are going to this chamber, then you will get uranium-235 amount increased from 0.7% to greater extent. So initially they were having 0.7% uranium-235, but now onwards it start increasing out, and ultimately we are getting considerable high amount of uranium in the sample. We are saying this as enrichment of uranium. So this concept is called as enrichment of uranium. So here we are getting this way enrichment of uranium. This is one method I have shown, but various other methods are also now developed, that is use of electrical current and so on. So this way uranium is separated out. Uranium-235 is separated out from uranium-235. This process of enrichment of uranium is a bit difficult. But then we realize another concept, that if you have considerable amount of uranium-235, then it may explode suddenly. Why? Because if certain mass is there, then only this reaction proceeds. Name of reaction is chain reaction. Say what we discussed, that uranium-235 is bombarded by slow moving neutron to get barium plus krypton plus 2 to 3 neutrons. These neutrons are freed in this reaction. They are attacking on other atoms, and other atoms also start exploding out, and like that process continues. We are calling this a chain reaction. I am talking little bit fast, but still it is very slow. In order to complete nuclear reaction, nuclear chain reaction, millionth of second is sufficient. So this reaction is extreme fast reaction, and therefore what is the problem? That we can't store out uranium to great extent. So uranium-235 is stored in lumps of 500 gram. There is one concept that is called as critical mass. If we are keeping 1 kilogram uranium at a time, it may explode immediately because neutrons are present in atmosphere. In order to avoid this explosion, we are placing uranium-235 in 500 gram lumps. So it is again technologically problematic. Now, what way bomb is there? Say I am showing you just schematic diagram, it is not real one. And no doubt I am showing here, but it is really difficult to achieve technologically. Say simple structure is there, there is this, suppose this is the nuclear bomb. You may draw externally as it is. I am showing here, there is a curtain which is opaque to neutron, means it will not allow neutron to move over there. There will be a source of neutron. We are calling that as moderator. Simply heavy water is also sufficient for this type of purpose, which is continuously emitting out neutron. Here we are placing TNT, that is trinitrotoluene, world's greatest explosive, fantastic explosive in those days, we kept there. Then there is timer or trigger, rather I should say it is trigger. And here in this shape we are placing out series of uranium lumps like this way. Then there is motor. Now say neutron is there, neutron emitter is there, it is emitting out neutron in continuous fashion. But as this membrane is opaque to neutron, it will not explode. Whereas here we are having 500 gram lumps. So first thing is there, in order to blast this weapon, motor should move in this way that all 500 gram lumps will come together. At the same time, trigger should hit TNT, TNT should blast. On blast of TNT, this neutron membrane, neutron opaque membrane will blast, and now neutrons can hit over the collected mass of this uranium-235, and then in millionth of that second only explosion takes place. This is very easy for me to explain, but it is very difficult for a person to achieve technologically. In such a small tiny time gap, all reactions should carry out, all actions should carry out simultaneously, and that's why making of this type of bomb is and was bit difficult. Now scientists, American scientists were able to make this. No doubt all scientists were not American, but Now they are called as American only. And then they they tested out this bomb in desert of America, and they got success. This way, uranium bomb was prepared by America, but particularly after death of Hitler, because Hitler initially invested tremendous amount on the research of this nuclear bomb, but later on, as war proceeds, he was not able to pay much attention to this research work because their needs were different now. Whereas America, as it was away from actual warfield, and America was having well planned program as well as tremendous resources, and what is the important thing, a vision, they were able to produce this type of bomb.